Welcome. In this video, we're going to take a look at two of the examples from Lesson 2. You should be in your workbook and following along, writing down all of the notes that we take. Please pay attention and listen to the words, not just watch the video. In this lesson, we're going to talk more about proportional relationships. Proportional relationships have the same ratio for all the parts of it. So some examples of proportional relationships are the money you get paid for working. You get so many dollars per hour, no matter how many hours you work. If you work 1 hour and get paid $5 per hour, you'll get $5. If you work 2 hours, you'll get $10. If you work 3 hours, you'll get $15, and so on. In a proportional relationship, the value of every ratio is the same. So when we check a table to see if the relationship is proportional, we're going to find the value of the ratio for each one of our ratios. In example 1, we're looking at pay by the ounce frozen yogurt. I'm sure you've gone to some place like Bolly's Frozen Yogurt in San Luis Obispo or the other yogurt store in El Paso that you get your yogurt in a cup and then you put it on the scale and you weigh your yogurt and you pay so many cents per ounce. Well, this store sells its yogurt at a price based on the total weight of the yogurt and the toppings in the dish. Each member of Isabel's family weighed his dish, and this is what they found. They want you to determine if the cost is proportional to the weight. So these are 4 different people who weighed their yogurt and then looked at the cost. The first person had 12.5 ounces, and it cost $5. The second person had 10 ounces, and it cost $4. The third person had 5 ounces, which cost $2, and the last person had 8 ounces, which cost $3.20. If we find the value of each one of these ratios, we can tell if it's proportional. To find the value of the ratio, we're going to find the cost, the dollars per ounce. Dollars per ounce. OZ is the abbreviation for ounces. So for each one of these, we're going to do that. So for the first one, we have $5 for 12.5 ounces. If I do the division on my calculator, I can see that 5 divided by 12.5 is 40 cents per ounce. Remember, OZ is the abbreviation for ounce. So that's this first one. The value of this ratio is 40 cents per ounce. Now we can look at the second one. We have $4 for 10 ounces. If I do my division there, that is also 40 cents per ounce. On the third one, I have $2 for 5 ounces. If I do my math on that one, that is also 40 cents per ounce. Remember, I'm dividing my numerator by my denominator to find the value of my ratio. And on my last one, I have $3.20 divided by 8 ounces, and that is also 40 cents per ounce. Okay. Since all 4 of these values are the same, then I know that this is proportional. So the cost is proportional to the weight. That's because each of these has the same value. I have 40 cents here, 40 cents per ounce here, 40 cents per ounce here, and 40 cents per ounce here. If even one of these were not the same, then the relationship would not be proportional. Now let's take a look at example 2. In this example, instead of a table, we have a double number line. Hopefully you remember double number lines from last year. The first number line is measuring in cups. The second number line is measuring in ounces. This is from the back of a recipe book and provides easy conversions while cooking. So if a recipe calls for 4 ounces, you know that that's a half of a cup. If it calls for 16 ounces, that's 2 cups. What we're going to check to see is if this is proportional, if our relationship of ounces to cups is proportional. In order to see if these two values are proportional, then we need to check the value of the ratio. We have a value of 0 to 0. 0 ounces equals 0 cups. That's going to be 0, so we're not going to check that one. But it's important that when you have proportional relationships, they go through the point 0, 0. Next, we can check cups per ounce. So in all of these, we're going to do cups per ounce. So first, we have 1/2 of a cup is 4 ounces. If we do our division, 1/2 divided by 4, that's going to be 1/8. 1/8 of a cup per ounce. That means that every 1/8 of a cup is 1 ounce, or every 1 ounce is 1/8 of a cup. Now we're going to look at 1 cup for 8 ounces. Well, that's 1/8 of a cup per ounce. 1 divided by 8 is 1/8 of a cup per ounce. Let's check 1.5 cups. I'm going to turn that into a decimal, which is okay to do. 1.5 cups for 12 ounces. If I do that on my calculator, 1.5, 1 5/10, divided by 12, then I'm going to get 1/8. 1/8 is the same as 0.125 cups per ounce. If I took 1 and divided it by 8, I'd get 125 hundredths. Oh, sorry, thousandths. The last one, 2 cups for 16 ounces, is going to be a fraction. If I simplify 2 out of 16, that's the same as 1 out of 8 cups per ounce. Conversions are always proportional. That's what makes them a conversion. They're proportional relationships. If you're converting feet to inches, you're always going to have 12 inches in 1 foot. If you're converting yards to feet, you'll always have 3 feet in 1 yard. If you're converting hours to minutes, you'll always have 60 minutes in 1 hour. So we can answer this question by saying the ounces are proportional to the cups because the value of the ratio is the same for every ratio. Make sure that you go through this video again if you need to. Carefully listen, fill out the examples. We're going to work on exercise 1 in class, and then we will be looking at example 3 and the problem set. Have a great day, and I'll see you in class.